Alright, so synthetic division today, day 2 of this. Understand what synthetic division means. It's a process where you omit all your variables and your exponents. You can only use it, you're only using it when you are dividing by a linear expression. Okay? Make sure you're clear on that. You only use it when you're dividing by a linear expression. Alright, only use it when dividing by that linear. Okay, tell your neighbor what it means for something to be linear. Alright, what does it mean to be linear when you're looking at an expression? Yeah? X is to the first power. Now I heard a bunch of you say that. I heard a few of you talking about like it's going up by a constant amount and blah blah blah. Okay, that's in a table or on a graph. In an equation, it's x is to the first power. Okay, that's the only time you can use it. All right, so the only time that we're going to go through it there. So let's try a problem here. I want you to take a look at let's do 11 off the example side. This is not one that we've done yet. Okay, you put it in your notes. It says use synthetic division. We are taking the x plus 3 and we are dividing this. Okay, now what I want you to focus in on, I want everyone to note that we are going to use what makes that 0. Okay? So right here where it says also by reversing the sign of the divisor, you can add throughout the process rather than subtracting. Well, really what that means, and I put that in there because that's what the textbook talks about. Okay, what that really means is by finding out what makes your divisor 0, you can add through the process. So what makes this 0? Negative 3, right? So we're saying to ourselves x plus 3 equals 0. And what makes x 0? X would have to be negative 3. Okay, what makes that expression 0? X would have to equal negative 3. Okay, so we're going to take negative 3 out of this, just like solving, like if that was one of our solutions. We're going to take that and we're going to put it right here. Now, a lot of you yesterday, as you're doing polynomial long division, you probably started going through a process where you're like, okay, this part's always going to cancel out and this part always gives me this. There's becomes a redundancy to it, right? A part where you just like, okay, these cancel. And that's kind of what we're getting rid of here. We're taking the negative 3 and putting it here, and then we're going to take all our coefficients, a 1, 11, and a 24. And we're going to list them right there. So just these coefficients drop down. If they're negative, they're negative down there then. Okay, but right now they all happen to be positive, so we just drop them in. Then we're going to skip a line and draw an equal or a line there. Okay? Now the process just goes like this. You drop down the 1 and that starts the whole deal. Drop down that first coefficient. And you go negative 3 times 1 is negative 3. So you multiply from here to there, which goes there. And then you add 11 and negative 3 is 8. And then you multiply. Negative 3 times 8 is negative 24. And you add and you get 0. Our solution to this is, since this is an x squared and this is an x, okay, this x has to multiply by an x to get an x squared, or it has to be, since we are dividing by a linear amount, we're always 1 degree less than this. So this 1 represents 1x. It's 1x because it's always 1 less than this because we're dividing by a linear. This 8 represents plus 8. This 0 represents our remainder, which we don't have. That is our solution, x plus 8. That means x plus 8 times x plus 3 makes this, which we could have done by factoring. It would have been a lot faster, but that's all right. Okay? All right. Any questions on that? Seems kind of weird at first, but you'll get very fast at it. You should try this one, number 12. Get it set up. Okay, we start out by figuring out what makes this equal to 0. That happens to be 16. That 16 is going there. We take our coefficients, the 1, the negative 13, and negative 48. Stack them up there. Drop down our 1. Okay. 16 times 1 is 16. We add down, we get 3. 16 times 3 is 48. That gives us 0. The answer is y plus 3. It's always 1 less power than that. How many got it? A little faster? Pretty fast. I still think factoring is a little faster, but that's all right. We'd have to. I mean, if we didn't know that, we could factor. Yeah.
So why does the 1 just drop down?
The 1 just drops down to start the problem. Now, if we actually matched it up with a polynomial, the polynomial long division, like if we let's see, like that, we always know that this, if we're dividing by a linear, this y times that, that's going to be a y there. It's a 1y. So y times y gives us y squared. And then y times negative 16 gives us that negative 16y. And then we end up flipping that sign. So it just gives us that place where we know that these two things cancel, so we don't have to worry about this part in here. But it allows us to multiply by this, which is what we're trying to get over here. Okay? So we're doing that 1y, that's where that 1 is, by 16 to get our remaining, our piece here, so that we can get the 3 that we end up with right here. That make sense?
Mm-hmm.
Yeah.
What if it's like 2y squared or like y has a different function?
We're gonna do one of those here in a minute. Okay. Good question. All right. So we got two more with two more. I think we should. Actually, we got 3 more. I think we should try. So let's try this guy here, number 15. Okay, what makes this part 0 is the 2. So we put the 2 there. This is 1x cubed. Now you have to fill in those place value holders, right? So you have to plus 0x squared plus 0x. So make sure you put in those place value holders. And then negative 8. Ask your neighbor if they forgot that. If they accidentally forgot that, then that's why we're trying it, okay? Drop down the 1, 2 times 1. Okay, any questions up to there? So from that point, if this is a linear and you're dividing a cubic by a linear, this first term is going to be x squared. Okay, it's always 1 less than this because you're dividing by a linear. Okay, so x squared plus 2x plus 4. So once we get that first degree, everything just decreases from there. All right. Any questions? Okay. Very good. I think we could skip that one. I don't think we need to do that one. Let's do one more. Is this what you're talking about, Christy? Okay. Try that one. Do what you think you should. At least try to get it set up. All right, let's see if we at least got it set up correctly. What makes this 0? 3/5. Everyone gets that, right? 5x minus 3 equals 0. So to solve that, we add 3. You get 5x equals 3, and then divide by 5. X equals 3/5. So that is the piece that goes right here. Now some of you will go like, I don't want to do that. I mean, that's a fraction. Okay, well, it's a fraction. It's not that bad, though. Okay, and then we have 25x squared, and we need plus 0x, right? We need that place value holder plus 9. So we get 25, 0, and 9. Guys, when you're dealing with fractions, just remember it's a compact way of doing two operations. Whatever you have, you're multiplying it by 3 and dividing by 5. And it's usually easier to divide first than multiply. You can do whichever first. So like when I bring down the 25 and I know I need to multiply 25 by 3 and divide by 5, I'm going to divide first because it gives me a smaller number. 25 divided by 5 is 5 times 3, 15. Okay, then I add, I get 15. Well, once again, multiply by 3, divide by 5. I'm going to divide by 5 first, which gives me 3 times 3 is 9. Okay, be careful here. This is actually what? 18. Okay, now we don't have nothing zeroed out, which implies we're going to have a remainder. Okay, this right here, this was a squared. That's linear. This first term then is going to be, it's going to be x. Okay, it's linear. Right? It's always 1 degree less, which makes this a constant, which makes this a remainder. Okay? Anyone see any problems with that? Parker?
Well, like, if the answer, like, if you plug it back in, what's 5x times 25x? Wouldn't that not be 25x squared?
Yeah, that's a problem. Everyone see that? Everyone understand what Parker just said there? Okay? Can I state it a different way? If I multiply, even just ignoring the remainder for a minute, if I multiply 25 by 5x, if I multiply those two things, do I get 25x squared? No, I don't. That's a problem, man. Okay, so something's wrong with this. Why don't you talk to your neighbor about it real quick? See if we can figure it out. I'll let you answer here in a minute. But does anyone know what the first term should be? And that should help lead you to the answer, I hope. Or at least an idea. Okay, go ahead.
Okay, well this is the same number 5 from yesterday's assignment, like example 1. So basically the first two terms are just divided by 5.
They're just divided by 5. So where does that 5 come from?
The second, like, point it's divided by, the 5x.
Yeah, probably this 5 here. Now, that's just we're kind of going roundabout on this, right? So, Christy, this is what you're asking, right? Okay. So, yeah, you'd have to take out that extra 5 here from those two, which ends up giving you then 5x plus 3 plus 18 over 5x minus 3. Now, we don't have to take it out here because it's being divided by right here. Okay? So, we're going to take it out of the 18. All right. So, if you're going to use this process is really helpful if you have a linear here that has a coefficient of 1. I mean, it's really easy. It's a little more involved if you have another coefficient here. Okay, it still works. You have to go through an extra step of dividing by that 5 there. But I will tell you, students that have tried to do this on their tests, as they progress on their tests, they a lot of times forget that 5. they forget to divide out that last piece, and they don't go back and check it like we did where we said, well, hey, is there some kind of issue here? Okay? So this is your actual solution here. You have to divide by that leading coefficient there. Okay. Questions? Tyler?
Why did you divide the remainder too?
Because the remainder is being divided by it right here still. Yeah. Other questions? All right. So if you take a look at your assignment today is on the back. It's 1 through 12. You should be able to finish the majority before you leave today. If not, the whole thing. All right.